Let's take a look at number 26. Elijah spends $55.26 on a meal with his date. What does he spend if the tax is 8.125%? Be careful on this one. Oftentimes, when we type it into the calculator, we'll assume the tax is the same as Texas, which is 8.25%, not 8.125%. The important thing when working with these percents is to convert them to decimals and probably convert them into a 1 plus the rate quantity, just because, excuse me, sorry, I'm stretching. It's a faster calculation. He ends up tipping 18%, which again is 0.18. And again, I recommend add the 1 to that. So how much does he spend on the meal itself? Okay, so we want to write an equation for this. So it's going to be 1.18 of the meal plus tax. So this rate right here, the 1.08125, represents the cost of the meal plus the rate if we were to multiply them. So in this case, the total amount is the 55.26. Looking at our equation, 55.26 is going to equal. Now in this case, I put the order of the tip and the tax in different different orders, but it doesn't actually affect the answer because the order multiplication is what, an associative, commutative, whatever that math axiom is. 2 plus 3 is the same thing as 3 plus 2 times x. Anyways, multiplying it through, here we clean this up and we find out that the meal cost $46.27. Voyager 1, the furthest fabricated object from Earth, was launched on September 1st, 1977. It was 15.1 billion miles from Earth on April 15, 2024. Calculate Voyager's average velocity. Well, the average velocity is going to be the displacement of Voyager divided by the time Voyager was moving. And we look at our units. They want it in miles per hour. And they give us 15.1 billion miles, but we need to find out the number of hours that it has been moving for. Quickest way to do that is to use the dates command in a calculator. On the Inspire, it is dBd and then the arguments. On the Prime, it would be d days. And the good thing about the Prime is that when you pull up a function, you can push help and it will give you a tutorial on how to use that function. So when you use the the Inspire with the dBd command, the format that it takes the date in is going to be month, day, year. Now the neat thing about it is whether you mix up the days or the months, it doesn't affect the answer because it has some internal checks. It checks, okay, what are the sequence of numbers? And from there it's able to rearrange itself if the days and months are out of whack. You can even mix them. So to use this, in this case, 1977 would be 77, 2024 would be 24. The neat thing about calendar patterns is that they repeat every 100 years. So you only need to put the last 2 days of the year on the Inspire function. The Prime uses a slightly different internal date system, and it prefers the full date on the year. So anyways, going back to the Inspire, all of the stuff that I've been writing on here on the screen is for the Inspire. So dBd, and the date would be September 1st, so 01/09/77. No need for the space between here. Sorry, I just happened to erase some stuff. Oops. I just happened to erase the leading parts of the dates. And so the gaps are present. The second date happened to be April 15th, 2024. And here I happen to invert the date and the month entries. So over here this is September 1st. Over here this is April 15th. And it will calculate the days between those two dates regardless. Okay. From there you convert it to hours by multiplying by 24. And you take the 15.1 billion miles divided by that time and call it a day. 28. A lacrosse field is this many yards by this many yards, and a football field is this many yards by this many yards. What is the percent increase in the area? Well, the first thing we want to do is calculate the two areas. And whenever we are calculating a percent change or increase or decrease, we need to keep track of what is the first or number we're going to put in the calculator and how it relates to the calculation. You see, when we're doing changes, you put the original value first. So for instance, in this case, on an increase, the original value would be the smaller value because we're going to increase from that value to a new value. So in this case, recognizing that the football field is going to be smaller, I would do the calculation of its area first in the calculator. So 55.3, enter, 100, multiply. Then I would calculate the area of the lacrosse field, 60, enter, 110, multiply. And then from there, I would do percent change. Now let's say you happen to get it mixed up and you had the larger area first on the percent increase. Well, when you calculate the percent change, it's going to really be doing a decrease from the 6600 to the 5330. And the big problem with that is that the basis of comparison would be in relation to the 6600. That means that we would be dividing by 6600 instead of 5330. So it's not like you can just take the absolute value, because let's say a 10% decrease of 60, which would be 6, which would put you at 54, is not going to be the same thing as a 10% increase of 54. A 10% increase of 54 would be 5.4. 54 plus 5.4 is 59.4, which isn't exactly 60. You see? So you have to be careful as to how you put these numbers in there. Anyways, straightforward solution. Calculate area of the football field because it's smaller. Calculate the area of the lacrosse field. Do percent change. There's your answer. 29. They want us to get the height of this square pyramid. And they give us some information about the side length and the angle of the vertex relative to the base. They tell us it's 65.5. Recognizing that if we look at this at just the right angle, we end up with a right triangle. And they give us the angle. And they want us to find the height. So we're going to have to do a little bit of trigonometry to get the answer. And here's our diagram for it, the height in question. We don't know the base there. But if we look at the figure, we'll recognize that the base of that little triangle, not the pyramid, but of the triangle created by the dotted lines, that is going to be half the diagonal of the square. And they give us the side length of the square, 0.574. So if we do a little Pythagorean theorem, s squared plus s squared equals the diagonal squared. We square root that. That becomes square root of 2 times s. You do that enough times and you will feel confident recognizing that if they give you the side length, you multiply it by square root of 2 and you have the diagonal. Once we have the diagonal, we're going to cut that in half and that becomes the adjacent side. The diagonal was originally 0.812 units. We cut that in half, that becomes 0.406. Rearranging the tangent expression for the height, we get 0.406, which is the adjacent side, times tangent of 65.5. Calculate that bad boy and you get 0.819. All right, last one on this page. They want the surface area of the rectangular solid. The convenient side is recognizing that on a rectangular solid like this, there's 2 sets of faces for every one of these 6 faces. So that's going to be 3 sets of subfaces we're going to add. A bunch of stupid technical terms I just made up, right? But it's going to be like 2 of this face area plus 2 of this area plus 2 of that area. And all of that gets thrown in. And so the generic formula is 2 times the uber quantity, or the big quantity here. And these are the areas of the faces. And so you just throw that in there and you calculate it. All right. Thank you.